This question is from GATE 2019 Mechanical Engineering Paper Set 2, question number 52. The thickness of a sheet is reduced by rolling without any change in width using 600 mm diameter rolls. Neglect elastic deflection of the rolls and assume that the coefficient of friction at the roll workpiece interface is 0.05. The sheet enters the rotating rolls unaided. If the initial sheet thickness is 2 mm, the minimum possible final thickness that can be produced by this process in a single pass is dash millimeters. We'll write the given things first. Diameter of roll, capital D, is given to be 600 mm. Coefficient of friction at roll and workpiece interfaces nu is equal to 0.05, and the initial thickness HI is given to be 2 mm. Now we know that for rolling, change in thickness of the sheet is equal to square of coefficient of friction, that is nu square, into radius of roll, capital R. This is a standard relationship for rolling which you must know. So we can write initial thickness is higher, so HI minus HF is equal to 0.05 square. Diameter is 600, so radius will be 600 by 2. Finding out HF, we have HF is equal to HI, that is 2 mm, minus 0.05 square into 300. We get the final thickness as 1.25 mm. Let's put it here in the blank. The final possible thickness that can be produced by this process in single pass. So of course this relationship is for a single pass, is 1.25 mm. To learn more about rolling, you can refer to the NPTEL video, Metal Working Processes Rolling. It's from the course Fundamentals of Manufacturing Processes. The course is taught by Professor D.K. Dwivedi. He is from Department of Mechanical and Industrial Engineering of IIT Roorkee. I hope the solution helped you clear your doubt. Thank you.